VHDL code for Mealy machine. In case of Mealy machine, output depends upon present state and present input both. For example, we have considered here 1001 non-overlapping case. So 1001 is a 4-bit sequence. So here we will consider 4 state S0, S1, and S2 and S3. Like you have seen in Moore machine, we have considered 4 bits sequence. We have considered 5 state. But in case of Mealy machine, the number of state is equal to the number of bits of sequence. But in case of Moore machine, we considered one extra bit, one extra state. So you can see here for S0, when S0 detects 1 as input, then output will remain 0, and for 1 we will move on S1 because we have to detect 1 here. But when it detects 0, then it will remain on S0 and output will also be 0. And similarly for S1, when it detects 0, it will move to S2. But when it detects 1, it will remain on S1. And similarly for S2, when it detects 0, it will move to S3. But when it detects 1, it will goes on S1. And when on S3, when it detects 0, it will goes on S0. Why is on S0? Because our sequence will become 1 0 1 0 0. So it is of no use. So we will start our sequence from initial state S0, and our output is not detected here. So output will also be 0. But when on S3, when it detects 1, then our 1001 is detected. So our output becomes 1 here. So it will start again from S0. So hope you have understand this state diagram, and you have studied this in digital electrodes in a detailed manner. I am just showing here for in a very brief manner. So by using this state diagram, we will now create a state table. Like we will consider S0 to S3 our current state, and then for, like you can see here, here S0 to S3 we have considered present state, S0, S1, S2, and S3, and for input x equal to 0, we have taken here next state, and we have taken here next state for x equal to 1. So these this state table is created by using the previous state diagram. So this will be used in VHDL code. Like we will see now. So this is the VHDL code. So first we will define the IEEE library. So these are the syntax for IEEE library, library IEEE, and use IEEE.std logic 1164.all. So we know this. After that, library declaration, we have to declare entity. So we have declared here entity Mealy, and this is the name of our entity, Mealy non-overlap. So inside entity declaration, we have to define the input and output. So we have considered clock, reset, and input. These are our input variables, and output as in our output variable. And after that, we will end the entity. So after entity, we will write the architecture, and inside the architecture, we will write our all code that will be used for the implementation of Mealy machine. So here we have used type keyword. So basically, type keyword allows you to define your own data in VHDL, and these are interpreted and synthesized by synthesis tool. So this is an user defined. This allows us to create user defined data. So type. This is the syntax of type variable. Like a type, this is the name of type variable. So here we taken state type and age, and so we have defined inside this our 4 state like S0 to S3, and we have considered the signal current state and next state, which are of state type. So we define two variables, current state and next state of state type, like for of state type variable. Here now we will begin the process statement, and inside process statement we have taken clock and reset because our because on the clock, when the clock and reset changes, then our then we have to this is in sequential circuit, so we have to take the consideration of clock and reset both. So if reset equal to 1, then current state is S0. Else if rising is clock, then current state goes to next state. Means if our reset is active, then our current state goes to S0, matlab it will goes on initial condition. But else if the rising edge of clock, here we consider the rising edge of clock. So the rising edge of clock is detected, then our next state goes to current state. So this this we have defined both for both clock and reset, and now we will end this process statement. Now we will consider both current state and input, and we will write the case for current state. So case current state is when S0 goes to when S0, if the input is 0, then output is 0. So this can be seen by using the state table that we have created in previous slide. So else if else the output is 0 and the next state is S1. So when S1 the input equal to 0, then output is 0 and next state is S2. Else output 0, next state S1. Then we will end up the condition. Similarly for S2 and S3, we can write by seeing the table. And after that, we will end the case statement, and we will end process statement, and we will end behavioral statement. Sequentially, as we have started these, and like this, we will end. So for the 1001 overlapping case, S0, S1, S2, and S3. Similarly, we will consider 4 state, and we will draw the state diagram and state table of Mealy machine. So we this thing we have studied in digital electronics in a very detailed manner. I have told you earlier this. So like we can see this once how we can detect for overlapping case. When S0 goes to S1 for input 1, it goes to S1, but for input 0, it goes to S2, and here for on S2, if input is 0, it goes on S3. But when we consider the overlapping case, you have to see you can see that it is not going in case of S3, it is going on S0, but like in case of non-overlapping case, it is going on S0, but in case of overlapping case, it is going on S1. So this will create difference here. So here the next state is S1 in 4 cases, but here the next state is in 3 cases S1, and in last case is S0. So by seeing this, you can write the code for overlapping case. The code will be same, but the one thing, but there is a, one difference in the case statement. You can write here the next states and present state by seeing the excitation table. So hope you will understand this. So thank you.